Okay guys, I'm going to do the review questions that have been sent to me. It is a little after 7, so I'm done accepting questions. I have got to get home. So I'll do this, I'll answer the questions that I've received so far. One of those questions was already done in another video. So whoever asked for the last problem in the 4-7 homework, that one's done on video already, so I'm not going to redo that one. I want to do the questions from homework first. So number 4.8 homework, I think this is the only one actually. 4.8 homework, number 7. 4.8 homework, number 7. Says we have a 100-foot building, a man at the top of a 100-foot building, and he observes a car moving toward him. If the angular depression of the car changes from 15 to 33, so here it's 15, and the car moves, and now it's 33. How far does the car travel? I think I did this one too, actually. I can't remember. So how far does the car travel? So again, I'm kind of confined to right triangle trigonometry at this moment. So I'm just going to call this y. The tangent of 33 equals 100 over y. The tangent of 15 equals 100 over y plus x. Do I know anything? Nope, that's all I know. Yep, that's it. Okay. I can actually find y. I can actually solve this equation. So I'm going to go ahead and solve that one. So I'll multiply by y. That one only has one variable in it. So y tan 33 equals 100. And y equals 100 over tan 33. So I can actually find that value. So that length right here, which I called y, that length is 100 divided by tangent 33. I'm going to make sure I'm in degrees. I am. So that is 153.99 basically. Now, I'm going to rethink this a little bit. That's what I want to find for sure. That's what I'm looking for. But what if I called this whole thing like z? Can't I say that the tangent of 15 equals 100 over z? And that too is a solvable equation. So z equals 100 over tan 15. So now I can find z. 100 divided by tan 15. So z is 373.21. Now remember, I'm looking for this, but I know this, and I know the whole thing, so I'll just subtract those two numbers. So it's 100 tan 15 minus 100 tan 33. So minus 153.99. And it looks like that distance is 219.22 feet. Right, feet. Yeah. All right, so that was a little easier actually than some of them because I could actually solve my equation. I didn't need to do substitution and all that stuff. Okay, so that takes care of that one. All right, now I'm going to look at review 1, and I might do these out of order because I wrote them down how they came in. So on review 1, problem 13, So 13 says an angle X is in standard position between 0 and 2 pi, so it's somewhere around here. In which quadrant is the terminal side of the angle if the cotangent is negative and the sine is negative? So you can just do this by process elimination if you want. So am I in quadrant 1? Well, I don't think so, because both of these are supposed to be negative, and in quadrant 1, everything is positive. So not quadrant 1. All right, what about quadrant 2? Well, in quadrant 2, that side's positive and this side's negative. Hypotenuse is always positive. Would that give me a negative sign? Would that picture give me a negative sign? No, because opposite over hypotenuse would be positive. So it's not quadrant 2. All right, let's look at quadrant 3. So this is negative, that's positive. Now I need the sign to be negative. Here's my angle. Opposite over hypotenuse, is that negative? Yep. Adjacent over opposite, cotangent. Adjacent over opposite, is that negative? Nope, that's positive. So I guess I'm looking at quadrant 4. In quadrant 4, is sine negative? Opposite over hypotenuse is negative. Is cotangent negative? Adjacent over opposite is negative. So the question is, in which quadrant? The answer is quadrant 4. In quadrant 4, the sine and the cotangent are both negative. Now, certainly you could reason that out in other ways, but if you really don't know, then you can do what I just did. Work yourself around the circle, all the way around each quadrant, and see if it meets what you need it to meet. So that's review 1, number 13. Okay, now review 1, number 20B. We have an eagle in the top of a 32-foot tree. Here's the eagle. He sees a mouse on the ground that is 913 feet from the base of the tree. And our job is to find the angle of depression. Keep in mind, technically, the angle of depression is right here. It's not in the triangle, it's up here. But because of alternate interior angles, your angle of elevation and your angle of depression will always be the same. So I always put it right there. I know it's an angle of depression, but it matches the angle of elevation. So that's where I'm putting it. Okay, my job is to find x, right? That's what I'm looking for, an angle of depression, yep. So I'm gonna use tangent. So tan x equals 32 over 913. So I'll just second tangent, 32 over 913. And that is second tangent, 32 divided by 913, about 2 degrees. So the angle of elevation is just about exactly 2 degrees, 2.01, depending on how we're supposed to round. 100th, so 2.01 degrees. Okay, so that takes care of that one. All right, now I'm going to review 2. I think the rest of the questions all came from review 2. So review 2, number 14. I need to find the period of this. All right, so keep in mind that both of these pieces are periodic, so they both have their individual periods. The period of this one is pi. Period of the tangent's pi. And that means that every pi, the picture starts repeating. So whatever happened at 0 happens again at pi, 2 pi, 3 pi, 4 pi, and so on. Right? That's when the picture repeats itself. Now, what's the period of this one? Well, this is a cosine, so that period will be 2 pi divided by 4, which is pi over 2. That means that this chunk of the picture repeats itself every pi over 2. Every half pi, and so on. The first time, see how they're both lined up at 0? The first time they're both lined up again is the period of the difference. So the first time they're both lined up again, it looks like right here. So the period of that thing is pi. They're both starting over at exactly the same time, or exactly the same place at pi. The second one, same exact concept. The period of the first one, it's a sine. Now, I went ahead and factored out the 8. I don't have to. I do have to if I'm going to graph it, but I'm not. So I'll just go ahead and pull them out anyhow. So the period of this one is 2 pi over 8, or pi over 4. So every pi over 4, it does the same thing it did at 0. So it repeats itself every pi over 4. So pi over 4, pi over 8, or pi over 2, so 2 fourths, 3 fourths, 4 fourths, and so on. That's when this picture repeats itself. Okay? So whatever happens at 0, whatever the curve is doing at 0, it's doing again at pi over 4, pi over 2, and so on. Now what about this one? This one repeats every pi over 3. So whatever it was doing at 0, it's doing it again at pi over 3, 2 pi over 3, 3 pi over 3, and so on and so on and so on. Well, what's the first place they overlap? The first place they match up again, so whatever they're doing at 0, they're doing it. And then that happens again at pi. So the period of this one is pi. That's the first time that the periods realign. All right, that's number 14. Okay, now review to number 15. Change negative 110 into radians. Well, there are lots of ways to do this. The way I do it, and will always do it, pi is to 180 as something is to negative 110. My proportion never lets me down. There's nothing to memorize. I know that pi radians is 180 degrees. The question is how many radians are 110 degrees? So I'll just multiply, I would cross multiply and divide, but it's just easier. Just bring the 110 over. And the answer is negative 11 pi over 18. So how many radians is negative 110? Negative 11 pi over 18. Review to number 8 is a sketch problem. So I'm going to first of all pull out that negative 3. Double check my arithmetic here. If I multiply these two together, I get positive pi over 4, which is what I'm supposed to have. So I know I factored correctly. This is a cosine. I know, and we talked about it today in class, that cosine is even. And what it means to be even is taking the cosine of a negative has no impact. The cosine of 60 is exactly the same as the cosine of negative 60. The negative doesn't matter. So you're allowed, in a cosine problem, to erase it. If this were a sine problem, it would come out in front. But if it's a cosine problem, that negative has no impact. Cosine is an even function. Same thing happens on both sides of the y-axis. So putting the negative's irrelevant. Erase it. So now I've got a cosine curve that's been shifted to pi over 12. Now, it's a positive cosine curve. So it has this shape. Its amplitude is 15/7. And its period is 2 pi divided by 3. So what that means is, from here to here is 2 pi over 3, which I'm going to go ahead and think of as 8/12. The period is 8/12. So if I start at 1/12 and travel 8, this is going to be 9/12. Because the distance from start to finish is the period. And the period's 8/12. Halfway in the middle, in other words, the valley here, 1 and 9 is 10, half of 10 is 5, so this is 5/12 right here. Right in the middle, 1 and 5 is 6, half of 6 is 3. 5 and 9 is 14, half of that is 7. When you do these sketches, remember, these 4 sections represent the quadrants, so they have to be equal. So we went from 1 to 3 to 5 to 7 to 9. All is well. That's the picture. So that is number 8. Now, review 2, number 4. So here's my setup. The first question, I think I did the second one of these already, but I'll do it again. The first one is about arc length. It talks about S. So this is 12 pi. The radius is 14. And my job is to find theta. Arc length equals radius times radians. Plain and simple. That's it. Divide by 14. Theta is 12 pi over 14, which reduces to 6 pi over 7. Arc length equals radius times radians. That's it. And the second one I already did. Somebody asked about it today, actually, I think. This angle is 95 degrees. The radius is 4. The area of the whole circle is 16 pi. If I wanted this shaded area, you'd take half of 16 pi and say 8 pi. I don't want half. The fraction I want is 95 3/60ths of the whole thing. So I'm going to multiply 95 3/60ths times 16 pi. And then reduce as I go. So let's see, I know 4 goes into this 4 times, and this 90 times. I know 5 goes into that 19 and 18. 4 twice 9. I'm getting 38 pi over 9. But I am not going to stake my life on that. The process is 95 3/60ths of or times the whole area. Yep, 38/9 pi, that's right. All right, so that's that one, that's number 4. Now I need to do 20C. And this, I believe, is the last one that was sent to me. So 20C on review 2. So what's happening? Mike, there's a tower, Mike's out here looking up at the top of the tower. The angle of elevation is 47.5 degrees. He moves 100 feet closer, so he moves 100 feet closer, and now his angle of elevation is 67 degrees. What is the height of the tower? So this is one we're going to need a system of equations. So I'll call this y. And the tangent of 67 equals x over y. So x equals y tangent 67. That's one of my equations. Tan 47.5 equals x over y plus 100. So multiplying this over here to get rid of my fraction. X equals y tan 47.5 plus 100 tan 47.5. So I am multiplying this over to here. And then I distribute it. Now I can set them equal to each other. So y tan 67 equals y tan 47.5 plus 100 tan 47.5. Put my y's on the same side. Factor them out and divide. So y is going to equal, I'm going to factor it out and divide. So y is going to equal 100 tan 47.5 divided by tan 67 minus tan 47.5. Now that is going to be my y value. And I think the question was the x value. But that's going to be easy because x is simply your y value times the tangent of 67. So when I get my y value figured out, I'll just take times tan 67 and that will be my x value. So here we go. Some of us have trouble typing this in, so let's see what we come up with. And you're not here to check me, so I'm going to hope I get it right. So for my y, I'll just write it down for comparison purposes. I got 86.30056, blah, blah, blah. That's what I got for my y. I'll type it in one more time and make sure I got that right since nobody can confirm with me. Twice, so I think that's right. So that's my y. Now I'll simply say times tangent 67, and the height of the building is 203.31 feet. So when I solve my system, I got a y value, but I needed an x, so I know that x is y times the tangent of 67, so I just took my 86 times the tangent of 67, and that gave me 203.31. All right, so our test is next time I see you. I don't know, when is that? Did we talk about that? That is Thursday. So our test will be Thursday. Review, review, review. Make sure you know all of the stuff. There's a ton to know. And good luck. Have a great snow day.